Here says 5 students each took 10 shots at the netball goal. The table alongside shows how many times each student scored a goal and how many times they missed. Here, this table shows a student A, B, C, D, E, and for a 10 shot, student A scored 7 and missed 3, which is 10 for 10 shot, 10 shot, 10 shot. Oh, and for all of them, anyone has a chance to have 10 shots. And for B, 5 scored 5 missed, C 3 scored 7 missed, and D 9 and 1, E 6 and 4. It says for part A, draw a scatter plot of the data. So I say for A, the data point or coordinate for A would be 7 and 3 if I get it as an x-axis, an independent variable, and missed for y-axis and dependent variable. So 7 and 3, 7 and 3 is for a student A. I write here A. B 5 and 5, 5 and 5 for B, and for C 3 and 7, 3 and 7 here for C. Okay, it's for C. D 9 and 1, 9 and 1. It's for D. And E 6 and 4, 6 and 4, which is here, and which is E. Okay, I said x-axis gives me the squared, and y-axis gives me the miss. If I look at this point, we see here that when x increase, my y dependent variable increase. When x increase, my y decrease. So they related negatively. So relation between x and y is negative. Now I will go to solve other parts to see if they have a strong relationship or not, or the relation between x and y is strong or not. To part B, this question asks find R using the formula. We know R is Pearson correlation coefficient, which I have the formula says R equals the sum of product of deviation of x and deviation of y over the square root of the sum of. Now I rise up this deviation because I really want to ignore and remove the negative sign times the sum of the square power of this deviation. So I will go and fill this table to find all the value I need to put in this formula to find R. So first of all, I write X, the first column, I fill the first column for the value of X, which is 7, 5, 3, 9, and 6. I will go for the second column. Let me change my color. Second column, I put the Y, which is missed. So I say 3, 5, 7, 1, and 4. Now, the third column and the fourth column related deviation. As I said, deviation shows me the distance between any value with its mean. What's mean? Mean says, for example, x, the mean says the sum of all the value over the number of this value, which I show this with x bar, which says the sum of all the value here, x over n. If I substitute the sum of this value here, I say 7 plus 5 plus 3 plus 9 plus 6, which gives me 3 and 7 would be 10, 5 and 6 would be 11, 11 and 10 gives me 21, with 9, which is 30. So I put 30 here. For numerator, I will have 30 over how many data do we have? 1, 2, 3, 4, 5 over 5. And the question says 5 students as well. Anyway, I find the mean between these 5 students, which is 6. I will go for y and to find depend variable and to find the sum of this value. I will have 7 plus 3, 10, 5 plus 9, 5 plus 4, 9, plus 1 again 10. So the sum of y would be 20. So I write y bar, or the mean of depend value, which is the sum of all y over n, which gives me here 20 over 5, which is 4. So I find it. Now I am gonna find the distance of any value from the mean. That means 7 minus 6 gives me 1. 5 minus 6 gives me negative 1. 3 minus 6 gives me negative 3. 9 minus 6 gives me positive 3. And 6 minus 6 gives me 0. As I said, always the sum of deviation gives me 0. If you try for y, you will see again the sum of all deviation gives me 0. The reason we raise it to the power of 2 and then get a square root, because I want to remove the negative sign of this deviation. So I will go for third column, fourth column to fill it. I said my mean is 4 here, so I go for the y. We say distance from any value from mean. So 3 minus 4 gives me negative 1. 5 minus 4 gives me 1. 7 minus 4 gives me 3. 1 minus 4 gives me negative 3. And 4 minus 4 gives me 0. Now I am gonna find to fill the next column. I am gonna find the product of these two columns. So I say 1 times negative 1, negative 1. 1 times negative 1, negative 1. 3 times negative, 3 times positive 3, negative 9, negative 9 again, and the last one would be 0. If I add them up to find the sum of this product that I need here for this formula, the sum of this product, let me highlight it. If I want to highlight this part, which is here, I will find the sum of this product. So I say the sum of this product, which is negative 1 and negative 9, negative 10, negative 1 and negative 9, negative 10, which gives me negative 20. Negative 20. That I will fill, I put here. So I find the numerator of this formula. Now I will go for the next column that says rise up this deviation to the power of 2. So the second column to the power of 2. 1 to the power of 2 gives me 1, negative 1 to the power of 2, 1, negative 3 to the power of 2, which is 9, and 3 to the power of 2 gives me 9, and the last row would be 0. Again, I have here 20. We see I remove all the negative sign and exaggerate the value because I want to show the uh, related between x, my independent variable, and dependent variable. So I exaggerate this deviation. I will go for the last column. Again, I have to rise up this column to the power of 2, which is 1, 1, 9, 9, 0. Again, I will have 20. Now I will substitute this value here. So as I said, R equals, I found numerator already. I substitute negative 20. Let me erase this negative 20 here. Now I say for denominator, I have the square root of the first one, this sum of, the sum of this deviation when I rise to the power of 2, which is here. So I write here 20 times the sum of this deviation for me, which is here, and when I find the sum of it. So again, 20 a square root of the number to the power of 2. I can cancel out my index, which is 20. So negative 20 over 20 gives me negative 1. I will write here R equals negative 1. So I write here R equals negative 1. And I will go to answer the part C. To answer part C, first of all, let me erase this part to have a space to answer the part C. And I go for graph here. First on the graph, if look at the graph here, if look at the graph and I draw a line between this data, we will see this data follow the linear line. They follow the linear line. So I say for part C that asks describe the correlation between variables, explain why this must be the case. We say the correlation, let me find the text box here. I've drawn a text box here to write better. And I say perfect negative. Why? Because the sign of R is negative. And why? Because we see on the graph when x increase, y decrease. We see when x increase, when x is 3, y is 7. When x becomes 5, y becomes 5. When x becomes 6, y becomes 4. So when x increase, y becomes smaller and smaller and smaller. And when x becomes 7, y becomes 3. So I say, first of all, we see the relation between them is negative and it's so strong because R is close to 1 and we see this data follow the linear line, linear equation. So I write the perfect, not weak, perfect negative correlation uh, is between variable, which is for any 10 shot scored and missed. What's my variable? I open parentheses, which says scored and missed. Okay. Oh, scored and missed. So out of 10 shots, we said 10 shots, so out of 10 shots. Each time the number of goals scored increased by 1. each time the number of goals scored increase by 1, then I said the relation between them is 1. So then then the number of miss decreases by 1. By 1. Why? Because I say they have a strong linear relationship together and is negative. So if x increase, which is scored as I said here, then the missed will decrease.